Okay, so in this next example, we're given an equation that shows us the height of a ball that's thrown from a cliff over a certain amount of time. Because the ball is thrown from a cliff, do you think the ball is going to be thrown on the ground at zero? Do you think the height will be 0 when it's thrown? No, it's thrown. If we're looking at time and height, it's thrown from a cliff, so it's above the ground, right? What would be the time when the ball is thrown? Has any time passed at the starting point?
Yes, 5.
Before the ball is thrown, no time passes. So let's find out the initial height of the ball. If no time passes, then t is 0, right? And I want you to think about this. What's 0 times anything? 0 plus 0 plus 120. Height is 120. So when the time is 0, look here, the height is at 120 meters. That means that the ball was thrown from 120 meters off the cliff, and then it eventually is thrown and hits the ground, right? Right. The question says, how long, so am I finding time or height for how long? I want to know how long, so I want to know the time. How long will it take the ball to fall 20 meters below its initial height? Well, what was the initial height? The initial height is 120 meters, and they want to know how long is it going to take when it reaches 20 meters below that? Well, what's 20 meters below the initial height? Good. Subtract 20. It's going to be 100 meters. Okay? So the original equation was h equals negative 5t squared plus 21t plus 120. But now we're taking away 20 because we want to know when it's 20 meters below that. So 120 take away 20. The new equation we're working with now is 21t plus 100. This is the equation we're working with now. I want to know what is the time when the height is 100 meters. Sorry, I meant to plug in 100 over here. It's when the height is 100 meters, because now the height is 100. We want to know when the height is 100, so somewhere around here, right, 100, what is the time, okay? So if height is 100, I need to plug that into my equation, okay? So I'm going to erase this. Oops, sorry. Okay, so when height is 100, I need to figure out the time. Can you simplify this equation and set it equal to 0? Yep. And make this negative 5t squared plus 21t plus 120. If I want to get rid of this 100 from the left side, how do I get rid of 100? How do you get rid of 100? Subtract 100. So what do I have to do to the right side? Subtract 100. What's 120 minus 100? 20, right? Plus 20. And I got rid of the 100, so this is equal to 0. So this is the equation we're going to work with, because we want to know when height is 100, what's the time? So now we're working with this equation. This equation will tell us the time when the height was 100 meters. Okay, we replaced h with 100, simplified it, and now we have negative 5t squared plus 21t plus 20 is equal to 0. Can you solve for t now? Factor, good. We're looking for two things that multiply together to give us what's negative 5 times positive 20. 100, and they have to add up to what? Positive or negative? Positive 21. Look for factors of negative 100. Positive 25 times negative 4 is negative 100, and that adds up to positive 21. So we're going to decompose this. Negative 5t squared. Are we going to put 25 with that or 4? Which one has a common factor? Plus 25t minus 4t plus 20, right? We decompose this equals 0. Now that we've grouped our common factors, terms that have a common factor, factor this and factor this. What's the greatest common factor of negative 5t squared and positive 25? Negative 5t So negative 5t times what gives me negative 5t squared? Good. Negative what? Good. Negative 4 is the common factor. We're left with t minus 5. Okay, let's write this in factored form. What is it? Negative 5t minus 4 and t minus 5 equals 0. So negative 5t take away 4 equals 0, and t minus 5 equals 0. So we need to solve for t, isolate t. Negative 5t equals what? Negative 4, bring it to the other side, it becomes positive 4. How do I isolate t? Divide both sides by negative 5. So t equals negative what? 0.8, and t is equal to positive 5. So technically, these are the values of t. Remember, we can have two values, but we're talking about time of the ball thrown. Does it make sense to have a negative value for time? Is that possible? So this one doesn't work. There's one answer. You cannot say that it took negative 0.8 seconds. That doesn't make sense. You can't go back in time. So we would say that it took 5 seconds for the rocket to reach what? What was the height of the rocket at this point? 100 meters. Excellent. Okay. Here's a screenshot of the graph. Okay. Well, the rocket started up here. I had to zoom in, sorry. It started at 120 meters above the ground. If you look here, when did the rocket actually hit the ground? When does a ball. They're throwing a ball off a cliff. When does it actually hit the ground? It's like at 8 seconds. I can't really read this clearly. But remember I said a parabola is symmetrical. Technically, you can graph this side of the parabola, but once you're going on the left side of the origin, these values are negative, right? You can't go back in time. When 0 seconds pass, the ball is thrown off the cliff. So it's actually thrown from 120 meters above the ground, and it takes a few seconds to fall. Okay, we don't talk about going back in time. It doesn't make sense.
Made with Doodlecast Pro.